relative position. That's well, we wrapped it up last time with the box plots. Let me grab the book here. There's the text. Let me get the homework sheet too while we're at it. Did I click on that? Nope. There we go. We're making our way through this course, aren't we? My God, it's half over today. Sweet Jesus, the course is half over. Please, Jamie.
I actually have a question on, like, calculating.
Oh, sure.
Like, for the randomness and everything. Are we going to have to, well, when you put in your calculator to, like, find random numbers?
Oh, will I ever expect you to do that?
Yeah.
If I ever do, I will give you step by step. I screwed up once. I did screw up once, Jamie, on your first homework set, where I asked you to do a homework section in the book that needed you to generate random numbers, and I hadn't even talked about how to do that, and then I went back and fixed it and gave you a link to use. From now on, if we ever need to do that, we'll do it in class together, or I'll give you instructions. Okay. So don't memorize that kind of stuff. Yeah, we'll do it enough in here. I like using the TI as a simulator. On Tuesday, I'm going to bring dice and coins to class, and we're going to create what are called probability distributions based on experimentation. But we can also use the calculator to do that for us, which is kind of nice. So it's a nice tool. And a couple of you after the quiz on Tuesday were like, this is kind of neat. Like, you can actually generate something out of nothing, essentially, if you give it a couple of directions to point in. And yeah, so we'll use it enough in here. That's what your project 3 is quite a bit, actually. The simulations idea, where you're using a random number generator to simulate experiments. So on the first day of class, for example, I said, what were your guys' birthdays? And we ended up having a birthday match, yes? There's somebody who's got the same birthday as somebody else. And I said, wow, that's kind of weird, isn't it? And you're like, yeah. And I was like, well, is it? We saw it. Like, if it's weird, we shouldn't have seen it. But we did see it, so is it weird? And then you walked out of the room going, I'm really wondering if I should even take this class. And Carrie dresses like a freak on Halloween. But then the question is, it's not that weird. In a class this big, there's about a 50-50 shot of having a birthday match. And then you say, how could it be 50-50? Well, that's what that spreadsheet simulation in Project 3 will actually answer for you, is how can it be 50? And the question is because it's too hard for it not to be, which is not a very good answer right now, the ones that I'm going to get to in the game. So don't worry about that. It's a long-winded answer to your question. Anything in here give you grief? Please, take a look. JC, you just go like this. I saw motion. Sorry. That's okay, you draw. I see motion like an amphibian. But a British amphibian. Sorry. Oh, that will be. Oh, that will be different. This reminds me of the bigger walking. That's one thing I miss. There's no salamanders in bed. It's just a freaking bummer.
Where did that come from?
Because of all the amphibians. You go on right to salamanders. Oh. I did throw some videos up. Hopefully that was helpful. I don't know if you got a chance to look at them or not. Hopefully they're helpful. I'm going to try to stay in front of the homeworks from now on, so that when you do the homework, the videos are ready after, as opposed to a couple weeks I got behind in the videos and I was posting them after the fact. I'm going to try to stay in front of it. I got the Outliers ones done yesterday, so. Anything?
Problem 15.
15 in the text? Skylar?
Yeah.
This guy right here. All right, let's go to page 87 and take a look at that one.
Specifically B and D.
Specifically B, okay. So this is, you said it was number 15, yes?
Yeah.
Wait.
No, 97.
Oh, 97. I have to go to 107. That's what it is. I went the wrong way with the plus 10, not minus 10. All right, and it's 15, yes? 15 is this guy back here. B and D. That's the ones we're going to look at?
Yeah.
Fantastic. Okay. We looked at this partially before with the variability. I think it was part C, the standard deviation, the variability. But now we're looking at part, let's do A, B, and D. Let's do all three of them. Let's get with you guys. Okay, so which are true and which are false? So here are the three histograms, or the three graphs, two histograms and a box plot. Okay, now let's see, I'm kind of upset a little bit. I might fix this actually with the lineup of the box plot. You see what I'm saying? I'm gonna cut it and slide it over. I didn't realize it was like that. So you have to kind of envision that box plot shifted over, looks like about 2 units maybe. That one would have to go, and that's actually not even scale, it's 0 to 1 would be, yeah, I'll fix that. Thank you for pointing this out, I didn't even notice that before. So, number 1, medians for all three graphs are the same, true or false. And when I say the same, go statistically-ish the same. I don't expect you to calculate that, because you can't calculate it for the histograms exactly without putting some values in for frequencies. But that's okay. What do you think? Medians, same, different?
Same.
I think it's arguably the same. I think it's arguably the same. Roughly the same amount of data on left and right of 3. Arguably the same amount of data left and right of 3. And clearly 3 because they've told you it's 3 down there. So we're happy with that. All right, part B. We cannot determine if any of the means for the 3 graphs is different. That's kind of a weird statement, huh? We cannot determine. We cannot determine if any of the means is different. So in other words, we're trying to see if they have different means. And the question is, can we not do that? Would it be let's answer, would it be possible to tell if the means are different? And you might answer this different ways depending on how you look at this. What's your gut feeling? Can we identify differences in the means from these graphs? What do you think? What's your gut feeling tell you? Isabel, go. Please tell me what's on your mind. Tell me what's on your mind, my friend. Go ahead.
I would say yes.
You say yes. Tell me why. Go ahead. Go ahead. You got it.
Because you can go up to them and see how many are in.
We actually did part of this question last week, didn't we? We looked at the means for these two, and we showed that these two basically have the same average. But when they're saying means, I'm going to call that an average. So we basically showed that they have the same average. I mean, we did that kind of fictitiously by putting frequency values on. But even if you don't look at frequency values, symmetric, not bell-shaped, but symmetric. So the mean's got to be in the middle of those two, yeah? Fair enough?
Not the box plot.
But the box plot's a little bit more interesting, isn't it? We know the median is here. Where's the average, do you think? Jenny's got to vote for over here somewhere. Why does she vote that, Jenny? I like that. Why do you vote that?
Because the balance point with that tail going as far as it.
She's mentioning a tail of the box plot. I love that. What's greater on the right side than the left side of this data set? Even though we don't know exactly where the data points are, what is greater on the right side than the left side?
The magnitude, the outliers.
Good, the magnitude of the variation. I love the word outliers. Can I pause on that for maybe 20 minutes, Michael? Come back to it. Because I'm not convinced there are outliers on that data set, but I know that whatever data points are out there are going to be further away. Good, that's what I was looking for. The deviation on the right side is further, or is larger, I guess, than the deviation on the left, which means the data points here, making certain assumptions about clustering and lack of clustering, are going to be further over this way than these are over this way, which makes me think that Jenny's claim that the average on this one is getting pulled a little bit that way has some validity to it. But somebody might counter that by saying what? And it goes back to the word ish I used earlier. It might be to the right. This could be too much of a 244 question, and I apologize. It might not be that far to the right. Like it might be 3.1 or 3.2, where the other ones are 3, and you might say that's the same number arguably. You see what I'm getting at there? That's why I'm saying either answer's valid. You can arguably say that you can tell the difference between these two. So that question is actually false if you look at these two graphs. It's false because you can tell the difference between those two graphs. It's kind of true when you look at this to this, if you argue the way I just argued there at the end, but it's also false if you use Jenny's assumption that you could imagine the means getting pulled this way. Very often, I think I mentioned this to you, I shouldn't say very often, occasionally you'll see box plots with averages on them. They'll slap a little symbol where the average should go. So in this case, the average might be somewhere like here. In which case you can say, oh, I can tell where the averages are, either by calculation or by inspection. So really, any way you want to answer B is okay as long as you back it up. Does that make sense? That would never be an in-class type exam question. That's the wrong kind of in-class question, right? Because I don't like watching students struggle through. I don't know, this doesn't have a concrete answer. I know. I try to give you ones on the exams in class that have concrete answers, because I know that makes you feel better. This is a great out of class to spur discussion for, especially talking to each other. Scott, you a little convinced yet? Go ahead, Fred. Or are you still just taking it all in?
Who, me?
Yeah.
Oh, I'm good.
Totally misread your face. Sorry. I look around also, I try to monitor you guys for like, when the face goes like this, like longer, I'm like, okay, not buying it. And then I try to ask what's on your mind.
I haven't had as much coffee as you have yet.
Well, I've had enough. All right. We cannot determine if any of the third quartiles for the 3 graphs is different. All right. Which of those 3 graphs have a very easy to discover third quartile? Definitely C. And Kate, what is it? It is 6. Okay, it is 6. I think this is a patently false statement. Patently false statement. Why do I think that?
Because you can find one, but you can't.
You can find the quartile on... Actually, I can approximate the quartile on all of them, I think. I think we can approximate the quartile on all of them. I think, well, I don't think we have to. This is the best part. Now, I'm going mathy on you here. I'm getting a little mathy on you. Kate just told me the third quartile on the box plot is 6. And she says, we can't determine the quartile on the histograms. I think we can ballpark it. I think we can ballpark it. But don't miss the forest for the trees. Look at the data in the 2 histograms.
There's no value above.
There's no value above 5. Which means whatever the third quartile is in those 2 histograms, it's less than 6. So I say we can determine that they're different. I think the quartiles for all 3 are different. I think this one is definitely 6. This one is probably, I'm guessing, somewhere in this 5 range, because there's so much data up here. And this one down here, I'm guessing, is somewhere around 4. Now, I'm guessing. We could do a quick little calculation if you wanted to kind of put some data values in there and work through it. I don't think it's important to. All it's important to do is to test the truth or falsehood of that statement. We can totally tell that they're different. We can totally tell that they're different because the third quartile for the box plot is 6. We know the 2 histograms are less than 6. So right away we know at least the box plot data has a higher quartile than the other 2. So is everybody okay with that, first of all? Everybody's okay with that? Since there are no values of 6 over here, this one has to have the highest third quartile. Do, check. Boop. So right away that statement is false. And this goes back to the math, being a math geek. To disprove a statement, all you have to find is one counterexample. That's a strong claim. We cannot determine. Yes, we can. The box plot's data is different. Done. False. But I would go even further to say we can determine that in order, smallest to greatest, the third quartiles would go U, U, and U. And here's why I'm saying that. I don't know how many data points are in this histogram. Do I? No. Right, but I've got a relative size ratio of the bars, and I think in class, I think we called that 1, 2,
3, 4, 6.
3, 4, and 6, and then this was 2, 3, 4, 5, and 6, yeah? If I remember correctly. There were 15 data points here and 20, I think, here, something like that, something along those lines. So if you know that it's 1, 2, 3, 4, and 6 as far as frequencies go, that's 15 total. To find the quartile, you have to go 3/4 of the way up to 15, which is right around 12. So you go to the 12th data point, roughly right around there is where your third quartile is. And the 12th data point is going to be somewhere around 4. Maybe closer to 5, maybe it's 4.5, but it's somewhere around here, the 12th data point. Is that 12-ish, 4.5-ish, exactly. And in lieu of not having real data, that's the best we can do, is say it's somewhere in there. Now, wherever it is, where would if this has about 20 data points, then the third quartile would be on the 15th data point. It's 3/4 of the way up. Well, the 15th data point is in here. We call that 6, correct? So 14 and 15 would be spanning the gap between 4 and 5, so again, right around there. So that's why I would say if I had to vote, I would vote for A has the smallest Q3, B is slightly bigger, and C definitely has the largest because it's 6. Which exceeds anything in the previous 2 data sets. This has everything to do with when my son first rode his bike, believe it or not. Believe it or not. In lieu of data, it has everything to do with when my son first rode his bike. And it might have something to do with when you guys experience your children doing something at some point too. We'll come back to that by the end of the day or on Tuesday. So, great question. I mean, it's such a great question because I love the potential for multiple answers on this one. And the kind of hidden assumption that you have to kind of catch. It's like an assumption, a hidden display that you have to identify with on that one. So, whose head hurts? Yeah, that was a good one, wasn't it? Nobody's head hurts. Sweet, sweet. That was a good discussion. That's a good one. Statistics without touching pen and paper. That's good. What else gave you grief? Thank you for that, Scott. It was fantastic. What else gave you grief? What else gave you absolute joy?
Your outfit.
My outfit.
Thank you. Hey, I do my best.
Bringing my guitar and my amp to the department meeting in half an hour. That's going to piss everybody off. Big slides.
So with that,
Decent! I also drank a lot of pool yesterday, master swim, so because I'm going through puberty quite a bit.
that full water is good for you.
It is, yeah, especially when you swallow all the way like I did yesterday. Cleanse those kidneys right out. Clorox treatment. Speaking of which, interesting. Was it you guys I asked about the caffeine in pool water? This is an interesting bit of statistics I did not understand. I had to ask some A&P folks. So I swim in the morning, I drink a cup of coffee, I don't eat breakfast, I drink a cup of coffee before I go to wake up a little bit because I'm up at 4. And then I go hit the pool at 5:15, I swim till about 6:45. And I wasn't drinking water at all, other than the pool. But I didn't bring like a bottle of water with me. I would just go to the pool and swim, and every 20 minutes I had to get out and go pee. And I'm assuming it's because the caffeine was drying me out. And one of the guys in my lane was like, dude, just bring a bottle of water. I'm like, dude, if I pee without water, I want to pee even more with. And you don't. This blew my mind. You don't. They're shaking their head, no, you don't. Why?
Because it retains water.
Why though? This is the part that blew my mind, because it makes no sense to me as a math guy. Go ahead. What does not having the water in your body and drinking the coffee, why does that encourage your body to pee out? Or what does it encourage your body to pee out?
Get rid of the caffeine.
To get rid of the caffeine, flush the caffeine. How does your body know to flush the caffeine?
Antidiuretic.
In English though.
It tells the brain undiluted amounts.
It tells the brain is signaled, there's a cell, and there's too much caffeine in the cell compared to the amount of water in the cell. So we've got to flush the caffeine out to get it back to this equilibrium stasis point. Well, that's one way to do it. Homeostasis, there we go. I didn't know that. We'll call it stasis, that's a pretty good word. So what you have is you have the cell with a finite volume. If too much of it becomes caffeine, you have to either flush the caffeine out to get rid of it, or put more water in, and the cell can swell to a point and remain in homeostasis. There we go. But apparently if you drink too much water, you have to pee anyway, because then the cell swells too much, and it has to get rid of that and get back to a certain volume.
You don't have too much water for your caffeine, so the water's going to...
So it's still stasis then. It's still stasis. That's very, very cool. So counterintuitive, drinking about half a bottle of water over an hour and a half in the pool makes me not pee at all. But drinking no water makes me pee every 20 minutes.
Did you test it?
I did! And this is bizarre. Every single time I drank the water, I didn't have to pee, and every single time I didn't, I did. Now here's the trick. I can't call that a valid statistical study, because I knew what was happening, and my brain could have been triggering, oh, you're drinking water, you'll pee. In other words, overriding the homeostasis idea. I would need to have a double-blind study. I don't know how to do that. How do you not have water and think you are? I don't know how to set that up. But I'm just happy not to run it. They just put the cover back on the pool. For all summer long, the cover's been off, and when it dropped to 31 degrees and the cover was still off, getting out of the 75-degree water to go pee, exactly, Michael.
Not cool.
I almost peed myself getting out of the pool. Yes.
So, okay, is it diffusion where water goes into the cell wall?
I don't know.
Membrane?
You gotta ask these guys over
Why
here.
doesn't that happen when you're in a pool?
What do
If
you
you
mean?
can if you can lose water,
You do. You get pretty
would
fingers.
like go in.
Yeah. Oh, but you don't get it here.
Yeah, you're like keratinized.
Yeah.
Keratin makes you...
I love carrots.
It's a barrier.
I love carrots. Should I have some more?
Now,
Would you bring some for
It
me?
makes way more sense.
Human bodies are amazing things. It's just incredible to think about the level that we're talking about here. It's just, anyway, that was an interesting bit of statistics for you. I'm sure it was tested at some point.
Dehydrated in a pool, it's not cool.
I think you can just test, you can just do that, get a bunch of people
What
that don't
happened? I used to
know.
work at like this.
Exactly, and observe them, basically, observe them, yeah. But you have to control something like how much caffeine they're getting
You
per
could do like...
milligrams per kilograms of caffeine or something like
Get a group of
that.
your friends and everybody go to the pool and you all meet for coffee before, and then run to the pool
I
together.
told you that before, right? My friends think I'm out of my freaking mind. So, it would be a very small sample. But they're all equally insane, so it all works out well. Good? Yes, relative position we're happy about. It's not going away. It's not going away. We're going to stick with it. We're going to stick with it for sure. Let me pause this right now. But what I want to, actually, no, let's not pause it right now. What I want to do, we're going to leave the TI up to you too. We're going to talk about my good buddy, and this also, Jared, and this goes into what I heard about in that writing class yesterday. Let's see, lesson Outliers. This is a lesson I've created. Your book has precious little information. I think I just froze the computer. Your book has precious little information about outliers in it. I had to look very, very hard to find any mention of it actually. So, bigger? I can't? Oh, down here. That's right. My word. So, here's our buddy. Anybody that works at Subway, I am not picking on your company much. A little bit, I am. So, but I'm not picking on anything that's unique to Subway.